Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the practice questions on tree diagrams. If you need any extra help on tree diagrams, if you go to Corbettmaths and you look at video number 252, there's a dedicated video tutorial there on tree diagrams. Alternatively, you could scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, question number one. So question number one, we've got this tree diagram and we're told the probability that it rains on Monday is 0.4 and the probability that it rains on Tuesday is 0.8. And the tree diagram shows this information. So let's have a look at this tree diagram. She shows on Monday the probability of rain is 0.4 and the probability of no rain is 0.6. And that's good. They both add together to be 1. And in terms of Tuesday, the probability of rain is 0.8 and the probability of no rain is 0.2. So, and again, they add together to be 1. And again, 0.8 and 0.2. So we've got our tree diagram. And the question says, work out the probability that there will be no rain on Monday and no rain on Tuesday. So we want the probability of no rain and no rain. So if you want to find the probability of no rain and no rain, so this option here, what we would do is we would multiply the probabilities along the branches. So we're going to do 0.6 multiplied by 0.2. So we would do 0.6 multiplied by 0.2, and that's equal to 0.12. So the probability of no rain and no rain would be 0.12, and that's it. And we just find that by multiplying the probabilities along the branches. So let's write that down, 0.12, 0.12. Okay, let's have a look at our next question, question number 2. So question number 2 said James goes to an arcade. So James goes to an arcade and he has one go in the teddy grabber and one go in the penny drop. And the probability that he wins on the teddy grabber is 0.2 and the probability that he wins on the penny drop is 0.3. And we've been asked to complete the tree diagram. So let's complete the tree diagram. So the probability that he wins on the teddy grabber is 0.2. So that one's been done for us. So if the probability that he wins on the teddy grabber is 0.2, the probability that he loses on the teddy grabber will be 0.8 because those two probabilities have to add together to be 1. In terms of the penny drop, the probability that he wins on the penny drop is 0.3. So the probability that he loses on the penny drop, they have to add together to be 1. So if we do 1, take away 0.3, that'll be 0.7. And again, the probability that he wins on the penny drop would be 0.3, and the probability that he loses on the penny drop would be 0.7. So we've completed the tree diagram. So that's part A. And part B says, work out the probability that James wins on the teddy grabber and he also wins on the penny drop. So we want the probability of a win and a win. So this option here. So if we want to find the probability of a win and a win, we multiply these probabilities together. So we're going to do 0.2 multiplied by 0.3, and that'd be equal to 0.06. And that's it. So the probability that James wins on the teddy grabber and the penny drop would be 0.06. And we find that by multiplying these probabilities together. And let's write that down, 0.06. And that's it. Okay, let's look at our next question, question number 3. So question number 3 says, Ross posts birthday cards to Salvador and Pablo, and the probability tree shows the probabilities of each card arriving on time or late. So if we have a look here, we've got our tree diagram. So Salvador's card, the probability that it arrives on time is 2/3, and the probability that it doesn't arrive on time, or in other words, is late, is 1/3. And those two probabilities add together to be 1. So that's great. And in terms of Pablo's card, the probability that it's on time is 7/10, and the probability that it's late is 3/10. And again, they add together to be 1 because 7/10 plus 3/10 would be 10/10, and that's 1. So that's the tree diagram, the probability tree. And the question says work out the probability that both cards arrive on time. So in terms of both cards arriving on time, that would be on time and on time. So this option here. So we would multiply those two probabilities together. So we would do 2/3 multiplied by 7/10. And to multiply fractions, you just multiply the numerators and multiply the denominators. So 2 times 7 is 14, and 3 times 10 is 30. So that would be 14/30. So the probability that both cards arrive on time would be 14/30. Or you could simplify it to be 7/15. And if you got that, well done. Okay, let's have a look at our next question, question number 4. So question number 4 says Natalie has 8 socks in a drawer. So she's got a drawer and she's got 8 socks, and 5 of the socks are black and 3 of the socks are white. I don't know why she's got odd numbers of black socks and white socks. And the question says Natalie draws a sock at random from the drawer. So she takes a sock out at random from the drawer. She writes down its colour and then puts that sock back into the drawer. And then Natalie takes a second sock at random from the drawer and writes down its colour. And so we're then being asked to complete the tree diagram. Okay, so we've got the first sock. So altogether there's 8 socks in the drawer, 5 are black and 3 are white. So the probability of the first sock being taken out of the drawer being black would be 5 out of 8, or 5/8, because 5 of the 8 socks are black. And that means in terms of the probability of the first one being white, well, there's 8 socks, 3 of them will be white, so the probability of it being white would be 3/8. Okay, so that's the probabilities for the first sock. She looks at its colour and then puts it back in, so there's still 8 socks. So then probably the next one being black would be 5/8, because again there's 8 socks and 5 of them are black. And in terms of the white socks, that would be 3/8, 5/8, and 3/8. So the probabilities will just stay the same because she looks at the colour of the sock and then puts it back in again. So then that's the tree diagram completed. And then part B says work out the probability that the 2 socks are the same colour. So in this case, that would be either both socks are black, so a black sock and then a black sock, so that option, or a white sock and a white sock. So let's find the probabilities of each of those. So in terms of a black sock and a black sock, we would multiply those two probabilities together. So 5/8 multiplied by 5/8 will be equal to 5 times 5 is 25, and 8 times 8 is 64. So the probability of a black sock and a black sock would be 25/64. In terms of a white sock and a white sock, well, that'll be 3/8 multiplied by 3/8. 3 times 3 is equal to 9, and 8 times 8 is equal to 64. So the probability of both socks being black would be 25/64, and the probability of both socks being white would be 9/64. Now we either want this option or this option, so we can just add these two probabilities together, and then that'll tell us the probability of both socks being the same colour. So 25/64 plus 9/64 would be equal to 25/64 plus 9/64. Because they've got the same denominator, we can just add the numerators. 25 plus 9 is 34/64. Now we could cancel this down if we wanted to. Both of these numbers are divisible by 2, so that'll be 17/32. And that's it. So the probability that both socks are the same colour would be 17/32, or 34/64. And that's it. Okay, let's have a look at our next question, question number 5. So question number 5 says that a football team has 2 matches to play, and the probability that they win a match is 0.6, the probability that they draw a match is 0.3, and actually let's work out the probability that they lose a match. 0.6 plus 0.3 would be 0.9, so if we do 1 take away 0.9, that's equal to 0.1. So the probability that they lose the match, would be equal to 0.1, and those probabilities add together to be 1. Okay, next, we've then been asked to complete the tree diagram. So if we have a look at the tree diagram, the first match, they can either win, draw, or lose. These two probabilities add together to be 0.9, so again, probability for losing would be 0.1. And in terms of the second match, well, we're not told that the probabilities change, so perhaps they're playing the same team twice, I don't know. But the probability that they win the second match would be 0.6. The probability that they draw the second match would be 0.3. The probability that they lose the second match would be 0.1. And this would just repeat for all the other branches. So 0.6, 0.3, 0.1. And finally, 0.6, 0.3, and 0.1. Okay, so we've done part A. Part B says, find the probability that the team wins both matches. So that's a win and a win. So if we go back up, that's a win and a win. That's that option there. So it would be 0.6 multiplied by 0.6. So 0.6 multiplied by 0.6 would be equal to 0.36. And that's it. So the probability that the team wins both matches would be 0.36. Okay, next. So question number 6. Question number 6 says there are green and blue counters in a container. So there's a container with just blue and green counters, no other colours. And Kevin takes at random a counter from the container. He then puts the counter back into the container. He replaces it. That means he puts it back in. And then he takes a second counter from the container. And part A says complete the tree diagram. So if we have a look at this tree diagram, the probability of him taking a green counter is 7/8. Now because there's just green and blue counters in the container, these two probabilities will have to add together to be 1. Now, 1 is 8/8, so if the probability of the first one being green is 7/8, the probability that the first one is blue would be 1/8. Those two probabilities have to add together to be 1, and 7/8 plus 1/8 would be 8/8. And now if we just fill in the probabilities in the second branches, because we know that the counter is taken out, it's looked at and then it's put back in again, the probabilities will remain the same for the second branches. So it'll be 1/8, 7/8, and 1/8. And that's it. Okay, next, part B. Part B says work out the probability that Kevin takes counters that are different colour. So he wants the probability of getting counters that are different colours. So it's not going to be a green and a green. A green and a blue would work, so that one would work. A green and a blue, they're different colours. A blue and a green would work as well, so that would work. But a blue and a blue wouldn't work. They wouldn't be different colours. So that means that Kevin can either pick a green and a blue, or a blue and a green. So let's find these probabilities. So in terms of a green and a blue, that would be 7/8 multiplied by 1/8. So 7/8 eighths multiplied by 1/8. 1 times 7 is 7, and 8 times 8 is 64. So the probability of a green and a blue would be 7/64. And then a blue and a green, well, a blue would be 1/8 multiplied by a green would be 7/8. So 1/8 multiplied by 7/8. And that would be equal to 1 times 7 is 7, and 8 times 8 is 64. So we've got the probability of a green and a blue and a green. So it's either this option or this option. So if we want the probability of them being different colors, we just add these two options together. So 7/64 plus 7/64. So 7/64 plus 7/64. Just adding the numerators together because the denominator is already the same. 7 plus 7 is 14/64. And that's it. So the probability that Kevin choose counters of different color would be 14/64. Now we can cancel this. We can divide both of these by 2, and that would be 7. And that would be 7/32. And that's it. So the probability that you choose counters of different color would be 7/32. Now if we had another part C, and it said work out the probability that Kevin chooses counters that are the same color, what I would do is I would just take this away from 1. So I would do 1 take away the probability that they're different color, and that'll be telling me the probability that they'll be the same color. So I would do 1, which is 32 30 seconds, take away 7 30 seconds, which would be 25 30 seconds. And then that'll be the probability that they'll be the same color, those counters. But in this case, we would just ask for the probability that they're different color, and that would be 7/32 or 14/64, depending on which way you wrote it down. Okay, next. Question number 7. Okay, let's have a look at our next question, question number 7. So question number 7 says, Jennifer's playing darts and she throws 2 darts aiming at the bullseye. And the probability that Jennifer hits the bullseye on her first throw is 1/4, and the probability that she hits the bullseye on her second throw is 1/3. And part A says complete the tree diagram. So the probability that she hits the bullseye on her first throw is 1/4. So the probability that she misses it on her first throw would be 3/4, because they have to add together to be 1. And if we do 1 take away 1/4, that would be 3/4. In terms of her second throw, the probability that she hits the bullseye on her second throw is 1/3. So the probability that she misses the bullseye on her second throw would be 2/3, because again, they have to add together to be 1, which is 3/3. And then in terms of these branches, they're going to be the same as the one above, so that'll be 1/3 and 2/3. Okay, now if we have a look at part B says work out the probability that Jennifer hits the bullseye at least once. So in terms of hitting the bullseye at least once, that could be a hit and a hit, because this is at least once, she could hit it twice. A hit and a miss, that would work as well, that's at least once. A miss and a hit, that would work as well, because that's at least once, but a miss and a miss wouldn't work. So we want to find the probability of a hit and a hit, the probability of a hit and a miss, and the probability of a miss and a hit. And either one of these 3 options would work, so once we find their probabilities, we'll add them together. Okay, so in terms of a hit and a hit, that's going to be 1/4 multiplied by 1/3, and 1/4 multiplied by 1/3 to multiply the numerators. 1 times 1 is equal to 1, and 4 times 3 is equal to 12. So the probability of a hit and a hit would be 1/12. The probability of a hit and a miss, that would be 1/4 multiplied by 2/3, and 1/4 multiplied by 2/3, 1 times 2 is equal to 2, and 4 times 3 is equal to 12, so that'll be 2/12. Now we could cancel that down to be 1/6, but I wouldn't. The reason that I wouldn't cancel that down is if we have a look here, the denominators of this answer and this answer are both the same, so it'll be handy whenever we come to add them if we keep them as 12s. And in terms of a miss and a hit, that's going to be 3/4 multiplied by 1/3, so 3/4 multiplied by 1/3. So let's work out this probability of a miss and a hit. So 3 times 1 is equal to 3, and 4 times 3 is equal to 12. So we've got the probability of a hit and a hit is 1/12. The probability of a hit and a miss is 2/12, and the probability of a miss and a hit is equal to 3/12. And either this option or this option or this option would work, so we just need to add together these probabilities. So let's add them together. 1/12 plus 2/12 plus 3/12. And if we do 1/12 plus 2/12 plus 3/12 altogether, that'd be 6/12. And now at this point, now we've got the answer, I'd probably cancel it down. 6/12 is 1/2. So the probability that Jennifer hits the bullseye at least once would be 1/2. And that's it. Okay, let's have a look at our next question, question number 8. So question number 8 says 2 boxes contain cupcakes. So we've got 2 boxes of cupcakes. In box 1, there's 2 lemon and 3 chocolate cupcakes in that box. So there's 5 cupcakes altogether in that box. 2 of them are lemon and 3 of them are chocolate. And in box 2, well, there's more cupcakes in that box. We've got 6 chocolate and 5 vanilla. So altogether, that'll be 11 cupcakes. And Nafisha picks cupcakes at random from box 1 and then a cupcake at random from box 2. So she's going to pick a cupcake at random from the first box and a cupcake at random from the second box. And part A says complete the probability tree diagram. So we need to complete this tree diagram. So in terms of the first box, we want to find the probability of a lemon and a chocolate. So in terms of a lemon cupcake, there's 5 altogether because 2 plus 3 is equal to 5. And 2 of them are lemon. So the probability that the first one's going to be a lemon cupcake would be 2/5. In terms of the first one being chocolate, well, there's 5 cupcakes and 3 of them are chocolate, so that'll be 3/5. And if we just check, 2/5 plus 3/5 is 5/5. Fantastic. Okay, in terms of box 2, so in terms of box 2, 6 plus 5 is equal to 11 cupcakes. There's 11 cupcakes in box 2. The probability of one being chosen at random being chocolate would be 6/11, so 6/11. And in terms of vanilla, well, there's 5 vanilla cupcakes out of the 11, so that'll be 5/11. So we've got the probability of a chocolate and a vanilla, and that'll be the same for the branches below, so 6/11 and 5/11. And then in terms of part B says work out the probability that Nafisha picks exactly one chocolate cupcake. So we want the probability that she chooses exactly one chocolate cupcake. So we've got a lemon and a chocolate. So a lemon and a chocolate, that's exactly one, so that would work. A lemon and a vanilla, well no, a lemon and a vanilla, there's no chocolate there, so that's not going to work. A chocolate and a chocolate, well that's 2 chocolate cupcakes, we want the probability of exactly one chocolate cupcake, so that's not going to work. And a chocolate and a vanilla, that would work, there's a chocolate one, there's 1 chocolate there. So we want to find the probability of a lemon and a chocolate, and we also want to find the probability of a chocolate and a lemon, and either of these two options would work, so once we find the probabilities we can then add them together. So in terms of a lemon and a chocolate, so a lemon would be 2/5, and a chocolate would be 6/11, and we just need to multiply them together because you multiply the probabilities along the branches. 2 times 6 is equal to 12, and 5 times 11 is equal to 55. So the probability of Nafisha picking a lemon and a chocolate cupcake would be 12/55. Okay, and now in terms of a chocolate and a vanilla, so chocolate and a vanilla, that'll be this option here. So that's going to be the probability for chocolate would be 3/5, and the probability for vanilla would be 5/11. And if we multiply those together, we'll find the probability of a chocolate and a vanilla. So in terms of that, if we multiply the numerators, we get 15, and if we multiply the denominators, we get 55. Okay, so we've now found these two probabilities, the probability of a lemon and a chocolate cupcake, and also the probability for chocolate and a vanilla cupcake. Now we want to find the probability that exactly one of the cupcakes is chocolate, so that's that option or that option, so we just need to add these two probabilities together. So that's going to be 12/55 plus 15/55, so let's do that. 12/55 plus 15/55 will be equal to 12 plus 15 is 27/55. And that's it. So the probability that Nafisha picks exactly one chocolate cupcake would be 27/55. And that's it. Okay, let's have a look at our next question. So question number 9. And question number 9 says, in a small village, 1 bus arrives a day. So each day 1 bus arrives in this village, and the probability of rain in the village is 0.3. So the probability of it being rainy in the village is 0.3. And if it rains, the probability of the bus being late is 0.4. And if it doesn't rain, the probability of the bus being late is 0.15. So whenever it's rainy, there's a greater chance of the bus being late. And whenever it's not rainy, there's a lower chance of the bus being late. Perhaps it's quite a windy road and it has to drive slower to get to the village. Okay, so we've got this tree diagram and we've been asked to complete the tree diagram. So the probability of it raining is 0.3, so the probability of no rain would be 0.7 because they have to add together to be 1. The probability of it being late if it was rainy is 0.4, so the probability of it being on time would be 0.6 because they have to add together to be 1. And in terms of it, if there's no rain, the probability of it being late is 0.15, so the probability of it being on time, we would do 1 take away 0.15 would be 0.85. So we've completed the tree diagram. And in terms of part B says work out the number of days the bus should be late over a period of 200 days. Okay, so we're trying to find out if there's 200 days, how many times that bus should be late. So let's find out the probabilities of the bus being late. So let's find the probability of rain and late, so that option, and let's find the probability of no rain and late, so that option as well. So let's find the probabilities of the bus being late. So rain and late, so that'll be 0.3 multiplied by 0.4 is equal to 0.12. So the probability of it being rainy and the bus being late will be 0.12. The probability of no rain and late, well, let's multiply 0.7 by 0.15, and that's equal to 0.105. Okay, so we found the probability of it being rainy and late, and there being no rain and the bus being late. So if we add these two options together, the probability of rain and late and not rain and late, then if we add them together, that'll tell us the probability of the bus being late in general. So let's do that. So let's do 0.12 plus 0.105. So 0.12 plus 0.105 is equal to 0.225. So that means the probability of the bus being late is 0.225. Now, if we want to find out how many times we expect something to happen, we multiply the probability by the number of trials. So in this case, if we take the probability that the bus is late, which is 0.225, and we multiply that by how many buses there'll be, so remember there's one bus a day, so if there's 200 days, that's going to be 200 buses. So if we do our 0.225 multiplied by 200, that'll tell us how many late buses we'd expect. So 0.225 multiplied by 200 is equal to 45. So we would expect the bus to be late 45 times. And that's it. So how many days do we expect the bus to be late? Well, the answer would be 45. Now, that's obviously what we would expect. In real life, it may be the bus is late on more occasions, or maybe the bus is late on less occasions, or maybe that is exactly 45 times, but that's how many times we would expect it to be late, or should be late. Okay, let's look at our next question. Question number 10. So question number 10, we've got the spinner. So we've got the spinner with 3 sections. It's got a 1, a 2, and a 3. And the question says the probability of a 1, the probability of the spinner landing on 1 is 2x. The probability that the spinner lands on 2 is x. And the probability that the spinner lands on 3 is 2x. And we've been asked to calculate x, so we want to work out the value of x. Okay, so whenever we spin the spinner, it has to land on either a 1, a 2, or a 3. So that means that these probabilities will have to add together to be 1, because it's certain that it's going to land on one of these 3 numbers. So if we add these probabilities together, 2x plus x plus 2x, that's equal to 1. These probabilities, when you add them together, they'll have to be equal to 1. Now, if we add together 2x, x, and 2x, that's equal to 5x. And that's equal to 1. Now, if we divide both sides by 5, if we divide by 5 and divide by 5, well, 5x divided by 5 is equal to x, which is what we want to find. And 1 divided by 5, that's going to be a fifth, or 0.2. And remember, this is a non-calculator question, so if you can't remember that 1 divided by 5, you can just do 1 divided by 5. Remember 1.0, but decimal point. How many 5s go into 1? 0, remainder 1. And how many 5s go into 10? That's going to be 2. So that means that x is equal to 0.2. So we've been asked to calculate the value of x, that's going to be 0.2. And at this point, actually, before we carry on, it might be handy for us actually to work out these probabilities. So 2x, 2 times 0.2 would be 0.4. X, that's 0.2, and 2x, well, 2 times 0.2 would be 0.4. So the probability that this spinner lands on a 1 is 0.4, the probability that the spinner lands on a 2 is 0.2, and the probability that the spinner lands on a 3 is 0.4. So we've got those probabilities. Okay, let's carry on. Okay, so the spinner spun twice and the scores are added together. So that means the lowest score we could get, the lowest result we could get is a 2 there, because it could land on a 1 and a 1, and 1 plus 1 is equal to 2. And the highest result we could get is 6, because it could land on a 3 and then a 3, and that's equal to 6. When we add them together. And then if we have a look at the question, part B says work out the probability of the final score being 4, and we may use the tree diagram to help us. So let's fill in this tree diagram. Well, we found the probabilities already. The probability that lands on a 1 is 0.4, the probability that lands on a 2 is 0.2, and a 3, 0.4. So let's fill those in. So landing on a 1 is 0.4, landing on a 2 is 0.2, and the probability that lands on a 3 is 0.4. And we can actually fill in the other probabilities too, so 0.4, 0.2, 0.4, 0.4, 0.2, 0.4, 0.4, 0.2, and 0.4. Okay, so we've filled in the probabilities, and we've been asked to find the probability that the final score is a 4. So let's find the options that would give us a 4 as the final result. So if it lands on a 3 and then another 3, that would be 6. That's not going to work. A 3 and a 2, but that's 5. That's not going to work. A 3 and a 1, that's 4. So that option would work. So let's star that one. A 2 and a 3, no, that's 5. A 2 and a 2, that's 4. So let's put a star there. A 2 and a 1, no, that's only 3. And then finally, a 1 and a 3, yes, that would work. That's 4. A 1 and a 2, now that's 3. And a 1 and a 1, that's 2. That's not going to work. So that means it could either be this option, a 3 and a 1, this option, a 2 and a 2, or this option, a 1 and a 3. So let's find these probabilities. Okay, so in terms of a 3 and a 1, that's going to be 0.4 multiplied by 0.4, because multiplying the probabilities along the branches, and 0.4 multiplied by 0.4 would be 0.16. In terms of a 2 and a 2, that's going to be 0.2 multiplied by 0.2, so 0.2 multiplied by 0.2 would be equal to 0.04. And the probability of a 1 and a 3 would be 0.4 times 0.4, so 0.4 multiplied by 0.4 would be equal to 0.16. So we've got this option, or this option, and if we want to find the probability for either of them, we just add them together because either this option, or this option. So we need to do 0.16 plus 0.04 plus 0.16, and that'll tell us the probability of getting a final score of a 4. So let's do that. So 0.16 plus 0.16 plus 0.04, that's equal to, actually I'm just going to use the column method here because it is a non-calculator question, and even though I know what the answer is, 0.36, I'm just going to show you. So 6 plus 6 is equal to 12, plus 4 is equal to 16. Put a 6 down, carry a 1. 1 plus 1 plus 1 is 3, and 0 plus 0 plus 0 is equal to 0. So our answer is 0.36, and that's it. Okay, let's have a look at our next question. Okay, let's have a look at question number 11. So question number 11 says Alfie's going to buy a coin. So he's going to buy a coin, and when it's flipped, the probability that the coin lands on a tail is 0.79. So the probability of tails is 0.79. If we want to find the probability of it being heads, we would do 1 take away 0.79. Now this is a non-calculator question, so I'm actually just going to work this out because it might come in handy. So 1.00 subtract 0.79. So we'll do that subtraction. So 0 take away 9, we're going to need to borrow. So let's borrow from here. That's now a 0 and a 10. Cross that off. That's now a 9 and a 10. 10 take away 9 is equal to 1. 9 take away 7 is equal to 2. And 0 take away 0 is equal to 0. So the probability that the coin lands on tails is 0.79. And the probability that it lands on heads is 0.21. Now, if we have a look at it, we've got this tree diagram. So this is what Alfie draws. And the question says, give a criticism of Alfie's tree diagram. So we need to criticize his tree diagram. So in terms of his tree diagram, if we have a look at it, well, the probability of it being tails is 0.79. I agree with that. We're told the probability if it lands on tails is 0.79. But have a look here. The probability if it lands on heads, he's got it being 0.11. And 0.11 plus 0.79 is actually 0.9. It should actually be 0.21. And that should be 0.21. And that should be 0.21. So his tree diagram, he's actually got the wrong probabilities for the coin landed on heads. So let's write that down. And that's it. So I've written down the probability that the coin lands on heads is 0.21, and Alfie wrote 0.11. So he's actually used that wrong probability. Okay, let's have a look at our next question. So question number 12 says the probability that a train arrives late is 0.2. And James is travelling by train on Saturday and Sunday. Show this information on a probability tree diagram. So we need to draw a tree diagram below. So let's do that. Okay, so I've started drawing the tree diagram, but I haven't included the probabilities yet. So we've got Saturday and Sunday, late and on time, late and on time, late and on time. Now let's put the probabilities on the diagram. So we're told the probability that arrives late is 0.2. So late is 0.2, so on time would be 0.8, 0.2, 0.8, 0.2, and 0.8. Okay, so that's part A done. Part B. So part B says calculate the probability that the train is on time both days. So on time both days would be on time and on time. So it's that option there. So we're going to do 0.8 multiplied by 0.8. So 0.8 multiplied by 0.8. And 8 times 8 is 64. So 0.8 times 0.8 would be 0.64. And that's it. And that's it. Okay, let's have a look at our next question. Okay, let's have a look at our next question, question number 13. So question number 13 says a college course consists of 12 weeks of teaching and then a final exam at the end of the course. If the student fails the exam, they have one opportunity to retake the exam, so they've got another chance to resit it. And the probability that a student passes the final exam is 0.8, so the probability that they pass this final exam is 0.8, and the probability of a student passing the retake is 0.4. And we've been asked to complete the tree diagram. So we've got the final exam, so that's the final exam at the end of the course. The probability of passing would be 0.8, so the probability of failing would be 0.2 because they have to add together to be 1. In terms of the retake, the probability of somebody passing the retake is 0.4. These two probabilities have to add together to be 1, so 1 subtract 0.4 would be 0.6. So we've completed the probability tree diagram, and then we're told if a student passes the final exam, so if they pass the final exam or the retake, they receive a certificate. So they can pass either one of them, the final exam or the retake. And we've been asked to work out the probability of a student receiving a certificate. So let's go up to the tree diagram. So that's either the probability of someone just passing that final exam, so that's that option, or they could fail the final exam and then pass the retake. That's that option. But they can't fail and fail, obviously, and get a certificate. So we want to find this probability, which is actually just 0.8, and we want to find this probability here of a fail and a pass. So a fail and a pass, we're going to multiply these probabilities together. 0.2 multiplied by 0.4 would be equal to 0.08. So that's either this option or this option. So we can just add them together. So that would be 0.8 plus 0.08 is equal to 0.88. So that's the probability of a student receiving a certificate, 0.88. And that's it. Okay, let's have a look at our next question. Okay, so let's have a look at question number 14. Now, question number 14, it's quite a long question with a lot of information, so bear with me as I read through it. Okay, so let's have a read through the question. So Isaac's designed a game to raise money for charity during a school fair. There's two boxes containing counters, box 1 and box 2. So we've got box 1 and box 2, and they contain red and green counters, so just red and green. And the two-way table shows information about the number of each colour in each box. So in box 1, there's 160 red and 40 green. So altogether, there's 200 counters there altogether. And then in terms of box 2, there's 50 red and 25 green, so there's 75 altogether there in box 2. And to play the game, each person selects a counter at random from each box. So the person's going to come up and they're going to pick a counter at random from box 1 and a counter at random from box 2. And then we're told that if both counters are green, they win a prize. So to win this game, they've got to get a green counter from box 1 and a green counter from box 2. The counters are then returned to the boxes, obviously, otherwise the number of counters are going to keep going down. And it costs £2 to play the game, and each prize is worth £8.50. And in total, the game is played 180 times. We've been asked to work out an estimate for how much money Isaac should raise for charity. Okay, so let's have a look. We've got a tree diagram here, and let's write down the probability. So let's fill in the probability of, in terms of box 1, the counter being red and the counter being green. So if we have a look at this, in box 1, there's 200 counters, and 160 of them are red. So in terms of the probability, in terms of box 1, the probability of red, and that notation just means the probability of red, the probability of the counter being red, would be 160 out of 200. Now if we cancel that down, that's going to be equal to 4/5. So the probability that a red counter is chosen at random from box 1 would be 4/5, and the probability for green would be, well, there's 40 green counters out of the 200, so that's going to be 40 out of 200, and that cancels down to be 1/5. So we've got those probabilities in terms of box 1. The probability for red would be 4/5, and the probability for green would be 1/5. Okay, now box 2. So box 2, if we have a look at it, box 2, the probability of red, well, there's 75 counters altogether and 50 are red, so it's going to be 50 out of 75, and that cancels down to be 2/3. And the probability of it being green would then hopefully be 1/3 when we work this out. That's 25 out of 75, so 25 out of 75, and if we cancel that down, we get 1/3. So we've got the probability for red from the second box being 2/3, and the probability of picking a green from the second box being 1/3. So let's write down our tree diagram. Red, 2/3, and green, 1/3. Red, 2/3, green, 1/3. Okay, fantastic. We've labelled the probabilities. Now, if we have a look at this, the game's played 180 times. So actually, each person pays £2. So if we do 180 multiplied by 2, that's equal to £360. That's how much money he collects altogether. So he gets £360 from the people who play the game. Because obviously they play 180 times, they pay £2 each, that's £360 altogether in terms of his income. Now, each time he gives out a prize, that's worth £8.50. So we need to take away the prizes from this money to see then how much money is left to give to charity. So what we want to do is we want to find out how many prizes should he have to give out. So we really want to find out what's the probability of somebody winning. So let's find the probability of somebody winning, and remember that's the probability of a green and a green, so that's that option there. So we're going to do 1/5 multiplied by 1/3. And 1 times 1 is equal to 1, and 5 times 3 is equal to 15. So the probability of somebody winning the game is 1/15. So that means that 1 out of every 15 people should win. Now altogether, the game's played 180 times. So if we take that 1/15, the probability of somebody winning, and we multiply that by 180, we can then find out how many times somebody should win a prize. Now in terms of this, it's a calculator question, so we could type this into our calculator. And that's equal to 12. So there should be 12 people that win a prize, and that means that 12 prizes are handed out. Now, another way to do that is, obviously, if this was a non-calculator question, the game's played 180 times. The probability of somebody winning is 1/15, so 1 in every 15 people should win a prize. So if we just take the 180 and divide it by 15, that'll give us 12 as well. So that means that 12 prizes should be won. Now, obviously, it may be more than 12 prizes, it may be less than 12 prizes. It obviously depends on the luck of the people pulling out the counters from the box. But based on the fact that the probability of winning is 1/15, we would expect there to be 12 prizes won. Now in terms of each prize is worth £8.50. So if we take our £8.50 and we multiply that by 12, that's equal to £102. So that means the value of the prizes, the cost of the prizes, should be £102. Now obviously it may be a little bit more or maybe a bit less, but that's how much the prizes should be worth. So if we take how much money he receives, the £360, and we take away the £102, what's left to be how much money he makes for charity. So he should make approximately £258. So that's how much money he should raise for charity. And that's it, that's our estimate. £258. And that's it. Okay, let's have a look at our next question, question number 15. So question number 15 says, Sally and Laura sit their driving tests, and the probability that Sally passes her driving test is 0.7. And the probability that both Sally and Laura pass their driving tests is 0.56. I've been asked to work out the probability that Laura passes her driving test. Now in this question, obviously Sally and Laura sit in the driving test. Those events should be independent to each other. Obviously the fact that Sally passes or fails shouldn't affect Laura passing or failing. And now obviously in some real life situations it might do. Perhaps they're using the same driving instructor. Maybe if Sally fails really badly, it might put the driving instructor in such a bad mood that he's more likely to fail Laura. I'm not entirely sure. But in this question we're going to assume that they're independent events. So that means that if we've got the probability of both of them passing is 0.56, if we consider the tree diagram, the probability of Sally passing and Laura passing is 0.56, and that's what we'd get when we multiply the probabilities along the branches. So that means that 0.7, the probability that Sally passes, multiplied by y, let's call the probability that Laura passes y, will be equal to 0.56. In other words, if you multiply the probabilities of each of them passing, you'll get the probability of both of them passing. Okay, so let's figure out what y is. So we've got that 0.7 multiplied by y is equal to 0.56. Well, 7 times 8 is equal to 56. So that means that y would have to be equal to 0.8, because 0.7 multiplied by 0.8 is equal to 0.56. Or another way you could do this is solve the equation. So divide both sides by 0.7. So divide by 0.7 and divide by 0.7. And on the left hand side, 0.7 multiplied by y divided by 0.7 would just leave us with the y. And on the right hand side, we've got 0.56 divided by 0.7. So we're going to divide that. Now you may know automatically that's 0.8. If you didn't, you'd have 0.56 divided by 0.7. We're going to multiply both of these by 10 because that would still give us the same answer, and I don't want to divide by 0.7, so that'd be 5.6 divided by 7. And if we do 5.6 divided by 7, that'll be the answer. So how many 7's going to 5? 0, remainder 5. And how many 7's going to 56? That's 8. So it's going to be equal to 0.8. So y is equal to 0.8, and that's it. Okay, next, part B. Part B says complete the tree diagram. So the probability of Sally passing is 0.7. The probability of her failing then will be 0.3. Remember, they have to add together to be 1. And in terms of Laura, the probability of her passing was 0.8. The probability of her failing is 0.2. Passing is 0.8 and failing is 0.2. And then we're asked to find the probability of both women failing. So it's going to be a fail and a fail. That's that option there. So that would be 0.3 multiplied by 0.2. And that would be equal to 0.06. So that means that probably both of them failing would be 0.06. And that's it. Okay, our next question. Okay, our next question says Kyle has taken free kicks for his local football team. So he must be the free kick taker. And he takes 70% of the free kicks with his right foot and then the rest of them with his left foot. And then Kyle scores 40% of the free kicks he takes with his right foot. And overall, he scores 32.5% of the free kicks that he takes. And we've been asked to work out the percentage of the free kicks taken with his left foot that Kyle scores. Okay, so there's a lot of information here. What I'm going to do is I'm going to do a tree diagram, and actually the template for tree diagrams there for us below. So first of all, we've got the fact he takes them with his left foot or his right foot. So let's put down our first branch being the foot he uses, so the foot. So we've got the right foot. The probability of using the right foot is 70%, or we could write 0.7 there, or 7/10. It's up to you. I'm going to write 0.7 because it's a calculator question, so I'm going to use 0.7. And that means the rest of the free kicks must be taken with his left foot. And right foot and left foot, well, they have to add together to be 1, so that'll be 0.3. That'll be 30% of them, 0.3. Okay, now we're then told that he scores 40% of the free kicks that he takes with his right foot. So now it's about whether he scores or not. So does he score? So then we've got score or not. So does he score yes or no? Yes and no. Now we could put down goal and no goal, goal and no goal, and so on if you wanted to, but I've just put down score yes or no, yes or no, so you can label it how you wish. So he scores 40% of the free kicks that he takes with his right foot. So he scores 40% of the free kicks that he takes with his right foot. So his right foot, he scores 40% of them. So it's going to be 0.4 for 40%. So that means he doesn't score, he misses with 60% of them. So we've now filled out that branch, and then we're told that overall he scores 32.5% of the free kicks that he takes, and we've been asked to work out the percentage of the free kicks taken with his left foot that Kyle scores. So I'm going to call that Y. So I'm going to call that Y. So that Y represents the percentage of free kicks that he takes with his left foot that he scores. So that's that Y. Okay, so if we have a look here, we're told that he scores 32.5% of the free kicks that he takes. So in terms of the free kicks that he scores, that'll be right foot and score, which would be this one, and left foot and score, which would be this one. Obviously, this one here is a right foot and not score or misses, and we've got the left foot and misses. So those options aren't what we're looking at. We're looking at these two here because these are the ones that he scores. And we know that he scores 32.5%. So that means that this probability plus this probability will be 0.325. So let's work out what these probabilities are. So in terms of taking a right penalty with his right foot and scoring, that'll be 0.7 multiplied by 0.4, and that'll be equal to 0.28. So that means that 28% of his free kicks he takes with his right foot and he scores overall. So that's pretty good. That means that if he takes 100 free kicks, he takes 28 of them with his right foot and scores, which is pretty good. Okay, so that's equal to 0.28. Now let's have a look at left foot and scoring. So we're going to do 0.3 times y. So 0.3 multiplied by y would be the probability that he takes one with his left foot and scores. So that would be equal to 0.3y. So we know that these two probabilities add together to be 0.325 because we're told that he scores 32.5% of the free kicks that he takes. So if we do 0.28 plus 0.3y, that's equal to 0.325. Okay, so now we just need to solve this equation and find y, and that's what we've been asked to find in this question. So let's take away 0.28 from both sides of the equation and see what we get. So on the left hand side, we're taking away the 0.28 to get rid of this 0.28, so we're just going to be left with 0.3y. On the right hand side, we had 0.325, we're taking away 0.28, so that's equal to 0.045. Okay, now we don't want this 0.3 here, we just want more to find out what y is. So let's divide both sides by 0.3. So divide by 0.3 and divide by 0.3. 0.3y divided by 0.3 would just leave you with y. And on the right hand side, a 0.045 divided by 0.3 would be equal to 0.15. So that means that this probability is 0.15. And that's it. And that's it. That's our answer, because we were asked what percentage of the free kicks that he takes with his left foot does Kyle score. So that is 15% of them. So he scores 15% of the free kicks that he takes with his left foot, and he means that he misses 85% of them. And that's it. It's 15%. Okay, let's have a look at our last question. Our last question, question number 17. So we've got George has got a bag of marbles. So he's got this bag of marbles, and there's 6 of them that are red and 4 of them are white. So he's got 6 red, so red, 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 and red. So he's got 6 red marbles and he's got 4 white marbles, white, 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 and white. And then he takes out a marble at random and records its color. So he's going to take out a marble at random, and then he's going to write down what color it is. And then without replacement, so this time he's not putting it back in, so he's not putting the marble back in, and then he takes out another marble at random, and we've been asked to complete the tree diagram. Okay, so in terms of the first marble, if we have a look here, he's got 10 marbles altogether, and the 6 that are red. That means the probably getting a red would be 6/10, so 6/10. We could cancel that down to be 3/5 if we wanted to, but I'm actually going to leave it as 6/10 for the minute because it'll actually help me with our next part. And then the probability for being white would be 4/10 because 4 of them are white out of the 10 marbles, so 4/10. Okay, now the second marble. So if he takes out a red marble to begin with, so let's go back up to our little diagram here, and he's going to take out a red marble. So he takes out a red marble, he doesn't put it back in, so this is what he's got left in the bag here for these branches here. So in terms of the second one being red, well, altogether there's now 9 marbles because he's taken one out, and he's taken out a red one, so there's only 5 left, so probably the next one being red would be 5/9. In terms of the second one being white, well, he's got 9 marbles in the bag, and there's 4 of them that are white. So if he takes out a red one to begin with, there's going to be 4 white marbles out of the 9, so that'll be 4/9. So we've filled out those branches. So if he takes out a red, probably the next one being red would be 5/9. And if he takes out a red, probably the next one being white would be 4/9. Okay, so I'm now just going to put that red marble back in because we're now going to consider these branches down here, and that's if a white marble's taken out. So let's put that red marble back in. Okay, so now let's consider these branches down here. So this is if whenever you take out a white marble as your first marble. So he takes out a white one, and so let's take out a white one. And he's been left with 9 marbles in the bag, 6 of them are red and 3 of them are white. So the probability of the next one being red would be 6/9, so 6/9. And then the probability of the next one being white, this probability here, if he takes out a white one, the probability of the next one being white would be 3/9, so 3/9. ninths. So this is what we call conditional probability. It's where the probabilities of the first event, the first marble being taken out, affects the probabilities of the next event. And so this is called conditional probability. So we've completed our tree diagram, so we've done that bit. And part B says, find the probability that the two marbles are the same colour. So we want to find the probability that the two marbles are the same colour. So that's going to be a red and a red, so that option, or a white and a white, that option, because those ones would be the same color, red and a red and a white and a white. Okay, so in terms of a red and a red, well, we'd multiply the probabilities together. So 6/10 multiplied by 5/9 would give us 6 times 5 is 30, and 10 times 9 is 90, so that's going to be 30/90. And if we cancel that down, that'll be a third, but I'm just going to leave it as 30/90 for the minute, because whenever I work out the probability for a white and a white, that's going to have a 90 on the denominator as well, so to make it easier whenever I'm adding them, not to cancel down at this point. Now in terms of a white and a white, well, it's going to be 4/10 multiplied by 3/9, just multiplying the probabilities along the branches. 4 times 3 is 12, and 10 times 9 is 90. So the probability of a red and a red is 3/90, and the probability of a white and a white is 12/90. So we either want this option or this option, so we add these two probabilities together. So 30/90 plus 12/90 is equal to 42/90. Now we can cancel this down. We can half them both to be 21/45, just dividing them both by 2. We can now divide them both by 3. That'll give us that's equal to 7/15. And that's it. The probability that both counters are the same colour would be 7/15. And that's it.